Okay, let's say we were given this problem. Find the equation of the line tangent to the curve x squared plus y squared minus 2x plus 4y equals 8 at the points 4, 0. So we can see that this isn't set to y, so we have to solve it implicitly. So let's start by taking the derivative first. That's going to be 2x plus 2y dy dx minus 2 plus 4 dy dx equals 0. Now, we were given points 4, 0. The best way to approach this would be to plug in your x value and your y value straight into the derivative from the beginning. So let's do that. So it's going to be 2 times 4 plus 2 times 0 times dy dx minus 2 plus 4 dy dx equals 0. And simplify, anything times 0 will cancel. So then 2 times 4 is 8. Minus 2 plus 4 dy dx equals 0. This becomes 6 plus 4 dy dx equals 0. Subtract 6 on both sides will give us 4 dy dx equals negative 6. Divide by 4. So our derivative would be negative 6 fourths, which can be reduced to negative 3 halves. Now we know that the derivative is the slope of the tangent line to the curve. So what we're going to do is we're going to put this slope into y equals mx plus b to find the equation of the line. So let's write that, y equals mx plus b. We have our 2 points here. Y is 0. Our slope is negative 3 halves times our x value, which is 4, plus b. Simplify this, so we get 4 times negative 3 is negative 12, divided by 2 is negative 6, plus b. Add 6 on both sides to get b alone, so b equals 6. So then we rewrite it, y equals, we take our slope, 3 halves x plus 6. And that is the equation of the line tangent to the curve.
So what we're going to do is find dy dx through implicit differentiation. And we know it's implicit differentiation because it does not equal y. So first we're going to find the derivative of 2y. The derivative of 2y is 2, and the derivative of y is dy dx, so it's going to be 2 dy dx. Now we're going to look at our second term, which is 9xy. To find the derivative of 9xy, we need to apply the product rule. The product rule states that it's the first term times the derivative of the second term plus the second term times the derivative of the first term. So our first term in this case is 9x. So we're going to write 9x, and the derivative of the second term, which is y, is dy dx. So we're going to do 9x dy dx. Plus, now we're going to take our second term times the derivative of the first term, which is 9, because the derivative of 9x is 9. So it's going to be 9y. Our third term is 4, and the derivative of any number is 0. So we're going to leave that by itself. And then we have 0 again, and the derivative of 0 is 0. So this equals 0. Now, just like solving any equation, we want to get dy dx by itself. So what we're going to do is we're going to subtract 9y. So minus 9y minus 9y. So on the right side, we have negative 9y. And now we have 2 dy dx plus 9x dy dx. So since we're trying to solve for dy dx, what we're going to do is factor out a dy dx. So we have dy dx. We're going to take the coefficients 2 plus 9x equals negative 9y. Again, we're trying to solve for dy dx. So what we're going to do now is divide by 2 plus 9x. And that is our derivative. Dy dx equals negative 9y over 2 plus 9x.